Hello again. This is the second part of the walkthrough of our hands-on workshop focused on Oracle machine learning for Python. And I'm going to show you the details about the data set and how to start writing your Python code in this short video. So we have the same instance here. We have the uh, remote desktop connection to our compute node on which we have the Oracle 21c database running and Jupyter notebooks interfaced around our Python code. And the next lab is understanding the data set. The data set is about an insurance company and customers they have, and it has multiple columns with many attributes, many details for their customers. The ones, the columns we're especially interested in are the lifetime value for their customers. So they have two columns with regarding the lifetime value of the customer, the numerical value, which is the exact business value the customer potentially has for the insurance company, and a label. Based on that numerical value, they are labeled in 4 different categories. So the insurance company wants to identify that numerical value based on the customer attributes we have in other columns, and and then they can decide which customers to target for different insurance products. You can see this the insurance data. We have here some screenshots and some examples of the data we have. For example, we have personal details of the customers, like first name, last name, and then we have the location of the customer, and then we have information like the marital status, if they have children, how big is their household, and personal data like that. And then we have the numerical value regarding the lifetime value of the customer, which is here on this column. It's an exact number the customer, if this is the like the potential the customer has to acquire insurance products on a yearly basis, based on their income, on the expenses they have over the year, and so on. And then we have this predefined 4 categories we use as a label to classify our customers. And the best customers, of course, are in the very high LTV bin. These are the bins we use as categories for our customers. We have the very high customers with a very high potential to buy insurance products, the high customers, and then we have the medium and low customers regarding the business value they can bring to our company. So we are trying to predict their value based on a pre-labeled data set. In this case, we're going to use mostly supervised algorithms to run Oracle machine learning in Python in order to understand the potential of a new customer based on the existing customers with previously identified values. We have this pre-labeled data we're going to use to create models and train our models. And using these models, we're going to predict the exact value of a new customer and the bin in which they belong to, the class in which they belong to. So this is what we're going to do during the entire workshop. We're going to use different algorithms, different data models, and we're going to create different Python scripts and run in Jupyter notebooks. And we are going to use those scripts to understand our customers and try to predict the amount of money they will spend on our insurance products, and how good the customer is going to be for our business. Of course, when we use this data set has like about 15,000 rows, 15,000 records, and it is already pre-labeled. Most of it is pre-labeled. We also have some records which don't have any labels. They don't have any LTV and LTV bin labels. And we're going to use those customers to test the model to see if the model works, if the Oracle machine learning model works as expected. But in order to test the models, we can also use pre-labeled data, dropping the columns with the label to see how accurate the model is, to test it against the pre-labeled values, to the existing, test the model with the existing values we already have in LTV and LTV bin without giving those values to the algorithm in order to test it. So this is the data set. This is the understanding the data set part. We can query this data in the database, which is already imported into our 21C database, and see what kind of information we have there and what kind of data we have there. So we're going to start with OML4Py part 1. This is the workshop we advise you to run as mandatory, at least this part, in order to understand a little bit of the Oracle machine learning for Python and how it works. So this also has some information about what we're going to do, what we're going to do during this lab. The hands-on lab itself takes about 3 hours to run, but between the reading the information here on the lab guide and running the exercises, the full time we expect you to finish this lab is about 4 hours. So we're going to connect to our Oracle 21C using the OML4Py code and the Jupyter Notebooks interface. And then we're going to perform classification, regression, clustering, attribute importance, and we're going to use also the AutoML. AutoML is automated machine learning. We have available for Python in case you have no experience and you are not looking to learn in details how algorithms are performing and how to manually create an OML model, an Oracle machine learning model. You can use AutoML, which is completely automatic. We just give the data and it will provide the data model, the Oracle machine learning model for you with the attributes it requires, with feature selection and model tuning for you, and you just run this model against your data to predict the results, the end results. This is the last part of this hands-on lab. So here we have all the sections, all the tasks. The first task is to prepare and explore the data, exactly what we have seen in theory in the lab 3 here in understanding the data set. This is more or less the same, but using the Jupyter notebooks and the Python code. Everything you see here on the lab guide is just for information purposes. You can read the contents and the explanations in the lab guide, but the same, all the code is already in your notebooks. And in case you want to test some custom code by yourself, please use the test notebook you have here at the end of the notebook list, notebooks list in Jupyter Notebooks. So you can use this test notebook to create. I have here some examples on what kind of code you can run, or some sample code blocks you can modify and change, and you can run any code you want on this notebook, on this test notebook. You have to import OML. These are the mandatory steps in every OML4Py code you run from Jupyter. First, you have to import the library, the OML library, of course, or the libraries you will need for your specific test. You can use NumPy or Pandas or any other libraries you will need for plotting images, for example, matplotlib. And then you'll have to connect to the database. The connection to the database, it is explained best in the first notebook in OML4Py part 1. So for now, let's go back to the notebook lists and click on the first notebook on OML4Py. This notebook explains using Markdown the instructions and the steps required to run the code for this hands-on workshop. And here we have more details about the database connection. So in order to understand how to connect to an on-premise database or to any Oracle database using Python code, let's say using the Jupyter interface, you need a few attributes here, a few details about the connection. You'll need the user, the password of the user. This is the schema you're going to use with the data to run Python code on the Oracle database. And you'll need the host name, the port number, and the database service name. These are the connection details. And also we specify here a flag in order to use the AutoML, the automatic machine learning modules I have explained in the previous part at the beginning in the lab guide here. So I'm going to specify AutoML true because we will run AutoML on this connection, on this Oracle database. We're going to use AutoML engine. I already know the user, and this is the password I have for the schema in the database. However, the host name and service name may change. If you deploy this custom instance, for example, this virtual machine on a different compute node in your own tenancy, your host name may change, or you may change it by yourself. And also the service name may change because of the networking details about and the subdomain and the domain you'll be using on your networking, on your VCN. I explained the networking details and the compute details in the previous video. So I need to get the host name and the service name of the database, including the full domain name of the virtual cloud network, using Python code. And I'm using the OS library to get the host name and the service name of my 21C database I'm going to use during this workshop. So I'm going to run this code here in the first section. And this code will give me the host name. I'm going to copy it here in my connection details. And then it also gives me the service name. I'm going to copy it here in my connection details. So now, at this point, I have the correct connection information for my Python code to run OML, Oracle Machine Learning, on my database I have prepared for this purpose. I have the schema, the username, password, the host name, port number, and the name of the service. And I'm going to run this code. And at the end of the code, I'm testing if the connection was successful or not. I'm testing the OML is connected method just to see if the connection succeeded to my database. Let's run the code and see what happens. So I get true. So OML is connected, is returning true. In this is the sign that my connection is successful to my database. If I want to further test my connection, I can run a very simple code just to return the version of the database. And I'm defining a cursor here. And I'm returning the version of the database for this connection. So I'm going to run this code, and I can see that the version of the database is 21C release 3. This is the database I'm using. If I want to run a query to return, for example, the tables I have in the schema, in the OML user schema, I have to use the CR, the cursor execute method, and fetch all, returning the rows for the query. So I'm returning the tables and the number of rows for each table I have in the schema I'm using for the workshop. I click run, and here I have the customer insurance LTV. This is the 15,000 rows I have in this table, the table I'm going to use during this workshop for all the labs. Then I have some data in a table called test data and some training data in a table called training data. This last two tables I'm going to use for a lab I have at the end of this workshop for sentiment analysis. This lab is using free text search and natural language processing to understand if comments are positive or negative. So the training data is pre-labeled, and the test data has labels, but I'm going to drop the labels just to test my model, my sentiment analysis model I'm going to create as one of the last labs of this workshop. So you'll have to wait until the end of the workshop to see how these two tables will be used. It is a very good practice once you execute some transactions using a cursor to close the cursor, and in this way to return the session to the pool. I'm using a pool sessions. I'm using the database resident connection pool for this database on this virtual machine. So I want to return the session back to the database in order to be used by some other user. In this case, I'm just the only user on this database, and there are no other users running reports and machine learning on this database. But let's say it is a good practice, and I included it here just to see how it works. And then I have some blocks in which I'm showing how to use data from external data sources. Let me make this screen a little bit bigger just to get rid of the scroll here on my blocks, on my Python code blocks in the Jupyter Notebook. I'm going to run And here I imported external data sources from the Py dataset. Py dataset is an open source library I'm using with sample data sources you can use for different machine learning trainings. And here we also have insurance data set which can be used to understand predictions regarding insurance use cases for Oracle machine learning. But this data source I'm going to just show you. So it's the insurance one. And this data source has, let's import it first in claims data frame. I'm going to use the data frame, a pandas data frame to import this data set just to show you the contents of this data set. This data set is very, very basic compared to the one we have in the data set we're going to use for this workshop. That's why I'm not going to use this one. I'm going to use this one just to give you some examples on how OML works and what we can do with Oracle machine learning to prepare a data set and to understand the data, to visualize the data at a very basic level at the beginning. But then we can run advanced predictions and visualizations, and we can create very complex reports on a data set using Oracle machine learning and using notebooks. You can use Jupyter notebooks you can install on a compute node like I did here, or you can use OML notebooks which are available by default with the Oracle Autonomous Database. So I'm going to import this data set from this open source data set into a table in my database. In order to do that, you can use the OML create procedure. And here I'm specifying the data frame and the name of the table. And as a precaution, I'm going to run a drop table just before that in case the table already exists in my schema. So let's run. And now I have this data set in a table in my database. So if I go back to you can go back also in Jupyter and run code from the previous blocks. So now if I go back to my block where I'm querying the tables in my schema, and if I run it, I have closed the cursor. I have to open the cursor again. So let me open the cursor here. And now I can run the query. Yes. So now I have the new table, which is open, which is created by the OML create procedure. And I don't have statistics. I don't know how many rows are in this new table. I have to run the gather statistics in order to understand, to get the number of rows of this new table here. So this is how you do it. When you jump between code blocks in Python, in Jupyter notebooks, for example, or even in OML notebooks we have on Autonomous Database, you'll have to make sure that the code you're running has all the components up and ready to run. For example, here the cursor was closed and I received an error, but I have to open the cursor again. So I have to run the code before that just to open the cursor again. And going back to the Python block, I was at the point when I created this new table here. You can see the blocks I already executed, they have a number here, the order of execution. This is the number they have here before the actual block, the Python code block. The blocks I haven't run already, they don't have no number. You can see the square brackets have an empty space. They don't have a number. So you notice this code was not executed in the notebook. So now I can do a select all from this table. This is the one I'm running, and I'm opening the cursor here. I'm just running a query to select all the rows from the new table. So I'm going to run it. You can see here I'm getting this number 13. This is the order in which the block has been executed, and this is the result. You get all the rows in the table. And let me see the type of the data frame in which this table is loaded in my Python code. And you can see here the claims data frame is a pandas data frame. By default, the external sources, they get imported into a pandas data frame. And the OML claims, which I used to create the table. So the OML claims is the component, the object, the Python object, which was created when I created the table. And this is going to be an OML data frame, which is different from the pandas data frame. Let me see the type of the OML claims here. So we can see here the OML claims is an OML data frame. It means that whatever Python code I'm going to run for these two frames, it has to be compatible with the data frame itself. So you have to know the methods and the attributes for each one of the data frames you have in Python. And usually in Oracle machine learning for Python in OML, we're going to use the methods, and we're going to use the procedures and functions we have in available for OML data frames. I can see the columns. For example, this is one of the attributes an OML data frame has. So I can list the columns. Let me run. And here I have 5 columns for the OML data frame. And let me see the values. I just type the OML claims, the name of the data frame, and it shows me the data I have in this data frame. I can run queries to see the details of the columns of the tables which are inside the database underneath this data frame, because usually data frame which is used in Python code to process the information underneath in the database will have a table which like in our case here. So let me see the details of the columns. We can see here in my table I just created, I have 5 columns that have been, these columns have been created automatically by the OML4Py procedure when I created the table using the data frame in my in the code I just ran above. And you can see here the data type and the size of the data for each one of the records I have in my table, for the records I have in my table. The other table I'm going to use for the rest of the workshop, which has more columns. Yeah, sorry for the scrolling up and down. My mouse is going crazy. So the other tables, the other table which I'm going to use for the rest of the workshop I was telling you about in the understanding the data set here, has more columns, because we have a lot more attributes in order to show you the full power and all the features we have in Oracle machine learning, because we can use a huge number of attributes. You can have data sets with maybe hundreds or thousands of attributes. Of course, we advise you to perform an attribute selection before you run a machine learning model, because if it has a huge number of attributes and those attributes are not required to produce or to improve the accuracy, the predictions will be very, very slow, and the resources will be completely overwhelmed by the machine learning execution. So in this case, we will reduce the number of attributes to the exact amount we need to improve the performance and also the accuracy at the same time, or to maintain the accuracy by reducing the number of attributes, improving the performance multiple times. And let's see so we created a list of columns here when we retrieved the number of and the type of the columns in each one of the tables. And let's see the type of this object. This object is a list. And let's see the type of one record in the list. I'm going to run this code, and each record in OML4Py, a list, it's a tuple. This is the name of the object. So we can, for example, we can create a pandas data frame using the list. So we can put this list into a data frame in a table format using pandas data frame. And this is the end result. This is the columns, but instead of being a list like here, they are a pandas data frame now. They look like a table, and they can be used to create OML data frames. For example, in this case, I'm going to create an OML data frame from the pandas data frame I just created from the list of the columns. And also, I'm going to apply some filtering. So, for example, using the OML claims data frame, I'm applying a filter. I'm going to query just the insurance customers with age under 25. And I'm going to use just 2 of the columns in that data frame to create an OML data frame on that information. And this is it. This is the holders, number of holders, and the number of claims for the customers that have an age under 25. And let's see the sum of the columns here. So we have over 1,000 holders and maybe under, well, above 230, about 230 claims open for those customers. I want to calculate maybe the factor of total claims based on the total number of holders. And we see here that we have under, well, about 20% of holders that opened a claim. So let's say one in 5 of our customers with age under 25 have opened a claim, an insurance claim on their insurance, on the company here, on this data set. Let's generate a pandas data frame from the customer's table. In order to generate a pandas data frame from a table, we're going to use the OML sync pool function, and this will give us a pandas data frame from that table. With the data from that table, you can see here we have a pandas data frame. If we want to generate if we want to see the first records of that panda data frame, we just need to run the head function of the pandas data frame, and this will display here the first 10 by default first 10 records. Let me see. I think it's the first 5. The first 5 is not the first 10. By default, is the first 5 records in our data frame. If I want to create an OML customer, an OML data frame, I from the same table, I'm running the sync function again, and this is going to be an OML frame. And then I'm going to display the first 5 records of it. And in this case, the head function run executed on OML data frame will display the first 5 rows in my data frame, but in a different way. So in pandas, for example, the head function and the first records are displayed using a scroll here, and then in OML data frames, the first records are displayed in a word wrap way. So you have the first columns on the first line, and then the next columns on the second line, next columns on the second line, on the next line, and so on. So it's like a word wrap using a backslash here at the end just to tell you that there are more columns. And also the columns are truncated. You have some dots in the middle because we are not showing you in this head display all the columns. There are more columns here in the middle. There are in total there are 31 columns in the data frame, and this information is displayed at the end of the output here. And then let's see the lifetime value of the customers. The 2 important columns we have in this data set. The lifetime value number value and the lifetime value bin, the classification we created for the customers. And here we have, for example, the minimums and the maximums. For example, the low bin for lifetime value has a minimum of 0 and a maximum of 13,999.50. So everything we have below 14,000, it's a low customer. This is the number we use to define the potential this customer has for an insurance product in our company. So the low customers, they have a potential of insurance products which can sum up to 14,000 I don't know, dollars or euros, whatever you want to define it, because it doesn't have a metric, a unit. It's just a number you can use in your company to define it can be dollars, for example, for the insurance products they can have for the full year. Whatever is between 14,000 and 22,000 has been defined as medium. This definition has been created by a human, by a business human agent. It's not by the computer. This has been defined by someone, by a person. High value customers are between 25,000 and 30,000. And whatever we have above 30,000 is a very high customer. This is the customers we are looking to get. These are the best customers. And in our data, the highest customer we have in our data set, the 15,000 customers, has about $47,000, whatever, as a value. And now we want to understand how is the distribution of these customers on the full number of, on the entire number of customers we have in our data set. So I'm going to use a plot here using OML, Oracle Machine Learning graphics, in order to show the distribution and see how these customers are distributed based on their value on an axis, for example, on the x-axis. So here you see on the y-axis, on the vertical, I have the value, the long time value, the number of customers. I have the number of customers on the vertical, and the lifetime value I have on the horizontal, on the x-axis. So you can see here most of the highest number of customers, they are in the middle area here, in the mid-range customers. So they are maybe the high customers between 22,000 and 30,000 as a lifetime value. You can see here just above 20,000. We have 22,000 here, and up to 30,000. We have a very small amount of customers above this line, over the 30,000 as a lifetime value, and we have more customers we also have a important number of customers, like a big number of customers below the 22,000 in the medium and low classes. So this is the basic understanding of the data we can run in OML4Py. And I'm gonna run the second task and the other tasks in the next video. Thank you very much.